VPN tunneling is a huge topic now in computer networking, and it's now included in the Cisco CCNA certification exam. IPsec VPN tunnels, and Cisco introduces the concept of tunneling with their own protocol, GRE, over IP tunnels, generic routing encapsulation protocol over IP. And so in this packet tracer exam, we're going to create a GRE over IP tunnel using packet tracer. If you would like to follow along with this video tutorial, you can download this graded packet tracer activity file at my website at danscourses.com. Just go to my website, click on CCNA4, and you should find the link to GRE VPN tunnel PT activity. Once you're here, you can download, read the introduction, and some instructions, and the download link is right here that you can download the zipped file, extract it, and you'll have access to the packet tracer activity file. You will need packet tracer version 6.1. Okay, let's get started. Now if we look at the instructions with this packet tracer activity, the instructions are here in a pop-up window along with the area where we can check the results to see how we did. It tells us that we do not need to configure router R2 and the PCs. They've already been configured, and router R1 and R3 have their gigabit interfaces and default routes already configured. So let's take a look. Now these instructions are also right here, right on the background of the packet tracer activity file. So R2 has already been configured, and R2 has no static routes or dynamic routing configured. So it does not know about this one network over here, and it does not know about this 192.168.3 network over here. PCA is 192.168.1.10, PCC is 192.168.3.10, and the R1 interface here is 192.168.1.1, and the R3 router interface right here on its gigabit 00 interface is 192.168.3.1. But R2 has no knowledge of these networks. So if we look at R2, and I'll just open up R2 briefly here and do a show IP route, you can see that R2 has no knowledge of the 192.168.168 networks. It only knows about its connected networks, the 201, 150, 200 networks. You can see those here. So as a consequence, PCA cannot communicate with PCC. So if I try to communicate from PCA to PCC and I try to ping, it's going to fail. So here's the ping, and the ping is going to fail. Okay, now R1 and R3 have host names configured and the interfaces configured, and they have default routes. The person that's missing, or the router that's missing routing, is R2. R2 does not know about these networks, but R1 has a default route going this way, and R3 has a default route going this way. Okay, so all we need to do, and it tells us here on step 1, is configure a GRE VPN tunnel from the R1 LAN, 192.168.1.0 LAN, to the R3 LAN, 192.168.3 LAN. And if it's successful, this tunnel will have these networks, this network information, basically encapsulated within the public IP networks, the 201 networks, and R2 will not know anything about the traffic going from the 1 network to the 3 network, because it'll be encapsulated within the packets. So all R2 will see is communication happening from the 201.150.200.0 network to the 201.150.200.4 network. And it will not need to know that 192.168.1 is communicating with 192.168.3 over a tunnel which will be configured on a 2 network. So it sounds complicated, but it's really not. So what we have to do is create this tunnel interface, which is essentially a virtual interface, and we need to tell it where the source point is and where the destination point is, and then we'll need to set up some static routing across the tunnel so we can communicate from PCA to PCC. So it should be fairly straightforward, and it's a nice introduction to tunneling. Now, with a GRE tunnel, with a Cisco protocol with the GRE tunnel, there's no security involved, so there's no encryption of the packets. So this is not a recommended way of setting up a VPN tunnel across the public internet, because GRE does not specify any types of security, right? So you to do that, it's recommended you do, let's say, an IPsec tunnel, right? Or maybe an open VPN tunnel or something like that. But this is great because it introduces us to the concept of tunneling and allows us to look at it before all the extra configurations that are involved in setting up an IPsec tunnel. So let's go right ahead and configure it. So I'll open up router R1, and I'm going to stretch this out and go right into the command line interface, enable conf t to get to global config mode, and I'm going to say interface tun 0 for tunnel 0, and that creates this virtual tunnel interface. All right, so now what do I need to do? Okay, so first of all, I'm going to put an IP address on this tunnel interface as required by the instructions. The instructions say the tunnel interface is going to be 2.1. So IP address 192.168.2.1, I'll give it a subnet mask. Okay, now I need to set the tunnel source. So I'll say tunnel, put a space and a question mark so we can check it out. You can see that I can set either the destination, the mode, or the source. We're going to do source, then I'll put a space and a question mark, and you can see that the next part is the type of interface. So I believe in this case it's gigabit 0 / let's take a look. The source is going to be the gigabit 01 interface here that points towards router R2, our actual physical interface that goes out to R2, which we'll say is like the WAN out here. So gigabit 01. So we'll say gigabit 01. And now I need to set the tunnel destination. Now when we put tunnel destination, I can put a question mark and you see it wants the IP address. Now the tunnel destination IP address is going to be the IP address of router R3's outward facing interface. So gigabit 01 on router R3, which is the interface that points also towards R2. So that IP address, if we were to look in R3, we'd see that it's 201.150.200.6. So that's what we'll put in. 201.150.200.6. And there's our tunnel destination. Notice we get a output message to the command line. The line protocol on interface tunnel 0 changed state to up instantly. Okay, now I'm going to set the tunnel mode. So I'm going to say tunnel mode, which is one of our options. I'll put a space and a question mark, and you can see that built into Packet Tracer we have two options here, GRE or IPv6 over IP. We're not doing IPv6 exercise here, but I'm going to do one in maybe the next video. So what we're looking at is a GRE tunnel, so I'll put GRE and then a space and a question mark, and you can see that the next command is IP, basically for over an IP network. So I'll put tunnel mode GRE space IP. So now I have the source, I have the destination, and I have the tunnel mode. So it looks like I'm done. So I'll exit out of my tunnel. And the other thing I'm going to need is I'm going to need to set up a static route to route across the tunnel from the 1 network, go across the 2 network over to the 3 network. So I need to give a route that tells basically the router how do we get to the 3 network. Now I'm not doing any dynamic routing yet, so I'm going to use a static route. So I'm going to say IP route 192.168.3.0, let's say. I've got to put in a subnet mask. And then the next hop IP address. So the other side of the tunnel, I'm 192.168.2.1 on tunnel 0. R3 will be the other end of the tunnel interface, and it's going to be 192.168.2.2. So I'm 192.168.2.1, and R3 is 192.168.2.2. So that is the destination next hop of the tunnel. So that's how we're going to get to the 3 network, by going through the tunnel to R3's tunnel interface, which we're going to configure at 192.168.2.2. So now it looks like I'm done. So I'll do a Control-C and a copy, run, start to save my configuration. Over to R3, we're essentially going to do the same thing. On R3, enable conft interface tunnel 0. The IP address 192.168.2.2. That's our tunnel interface. We need to put the subnet mask. There we go. Tunnel source gigabit 0/1. The tunnel destination, which is, let's see here, 201.150.200.1. Notice the tunnel goes up. Once again, the tunnel destination is the gigabit 01 IP address on router R1. So the source is our gigabit 01, and the destination is this one right here for R3, which we are right now. So got my tunnel source, got my destination, I got my IP address. The last thing I want to do is put in the tunnel mode GRE over IP. And I want to explicitly set that. Now I'll exit out of the interface and I'll put in my static route. IP route to reach the 192.168.1.0 network. Net mask 255.255.255.0. We're going to go to next hop router tunnel address 192.168.2.1. So there's my static route. So I'll close this window and we should have a tunnel up now. Actually, let's go back to R3 and let's do a quick check. Control-C, show IP route. You can see here that we have a static route to the one network via 192.168.2.1. We have connected networks. We have this connected network, the 2 network, which is connected on tunnel 0. So that's pretty neat. And then you can see the 3 network on our gigabit 00 interface, and then our 201.150.200.4 network right here, which is on our gigabit 01 interface. So it looks like all of our routing table looks positive. And then the ultimate test is I'm going to try to ping from PCA. And so we'll just do up arrow here. We'll see if we can ping across our tunnel. All right, now at first it didn't quite work, but then you see all of a sudden it started working. So there it is. We can ping across. I'll go to PCC and see if I can ping from this side. And see if I can ping host 192.168.1.10. And you see I can. Now the other thing that I can do, which is pretty neat, is what I'll do is I'll go into simulation mode and I'll go to show all or none. I'll say show none. And then I'll say edit filters. And I want to look at ICMP. Yeah, that's about it. I want to look at ICMP. So I'll go into PCA and I'll set up a ping again across ping 192.168.3.10. I'll hit enter. Now the ping is not going to start yet until I tell in simulation mode to either auto capture play or capture forward. Notice the packet queued up on PCA. So capture forward. So I'm going to hit capture forward. There goes the packet. There goes the packet. Right, there's our ping. Now let's look at this packet. So I'm going to click on the packet, and you can see from here that IP header source 201.150.201, destination 201.150.200.6, ICMP message type. So as far as it looks, it's going to 201.150.200.6. If we look at the inbound PDU details, you can see that's what we see here at the IP layer. Then take a look. There's the GRE protocol, and you can see that inside of the normal IP header is the GRE protocol information. And you can see that we have other IP related information going source IP address 1.10 to destination address 3.10. And that's basically encapsulated within the normal packet. So there it is, the GRE protocol, and then the hidden tunneled information, which allows the 192.168.1 network to communicate with the 3 network, even though router R2 has no knowledge whatsoever of those networks. Take a look. If I do a show IP route, you can see that router R2 does not see a 192.168.1 network. It does not see a 192.168.2 network or a 192.168.3 network. But yet there it is, allowing this communication to travel across, and it reaches all the way over to PCC, and we have a successful ICMP message sent across. Essentially what's happening is it's going across a tunnel. So they're able to communicate with each other as if they're on the same network, although it's going through a network infrastructure that has no idea about the underlying private networks that are in fact communicating. So it's pretty cool. We can also go back to the real-time mode, and then I'll bring up the PT activity, and you can see that we're at completion 100%, and we can check the results, click on assessment items, and we've configured all the necessary pieces to make it work.